This is the first in a series of webinars on Azure for IT professionals. Today we have Govind Kanshi, who's a principal program manager at Microsoft, joining us all the way from Seattle. Right, Govind? Um,
Yes, yes.
all right, to give us an introduction to Cosmos DB, and we will continue this series, and we'll hope Govind will come back again and give us some more knowledge in terms of Cosmos DB and what he's working on, etc. It's all yours, Govind. Please take it.
Thank you very much. So before I get started, I just wanted to understand how many of you manage databases of any kind? Just and we can make it interactive so that I can address specific issues. So let me ask a question like this, and without creating complicated voting and everything else. So if you manage a SQL server or Oracle server, if you can just say yes, or yeah. Okay, great. Or if you manage Mongo or Cassandra or HBase, any of those. Okay. So I'm assuming that the reason that many of you have joined this particular session is to make sure that you understand what this platform is at a very high level, and from the perspective of what uh, a daily grind of an IT pro is basically in terms of what all he has to face. So he has very little time, he or she, no gender issues here. Basically, whoever is doing this job is almost always, it is thankless in many ways. So you want to make sure that whatever time that you have is utilized properly. So how does Cosmos DB come into the picture, right? So the way I will do this session is I will describe some use cases. I will tell you what we do and then get into the issues, right? So just to make sure, so there are some folks who say that they are managing SQL Server, right? So I'm assuming when you manage SQL, Oracle, or for that matter, any other database too, Postgres or MySQL. So what are you worried about? Where is your time spent most of the time? Since I cannot see you, I'm assuming you're still listening. So let me prompt you by saying that most of the time you are worried about performance. Most of the time you're worried about availability. Availability, you set up all kind of things depending on what the database provides and ensure that availability is there. There are various techniques to do it. And then you are worried about the hardware, you're worried about the connectivity, you're worried about the software itself, the OS issues, and so on and so forth. When the new OS comes, how to update it. Pretty much holds a set of things, right? And performance is the other place that you are, and somebody mentioned fine tuning and performance. That is where you spend most of the time. And you would be spending time on index management, right? You would be basically finding out if the queries are using index, which queries are expensive, what they're doing. And then you also spend good amount of time on capacity management, seeing how is the box behaving, and should I order for new one, when is the time to do that, and so on and so forth. Challenges come, I'm assuming, for most of you in terms of saying when there is, let us say, there is a demand which increases uh, needs on your database server. So the way to see is if there is some season like today's, if you are one of the retailers, let us say you are doing a sale, you would need elasticity in your platform. So you would earlier, let us say you were supporting 1 million requests. Today, suddenly you have to support 10 million requests, right? And then after a few days, you have to go down. To manage this change and to plan for this is pretty difficult with regular software. So with having said that, let me get into what how we provide answers to all these questions. Okay, so let me know. I'm going to project the desktop as it is, and you'll have to excuse some of the prompts which might come in, and also if there is something else that you see. So let's see. Go ahead. Let me know when you can see the screen. Can you see the screen?
Not yet. Yeah, it's coming up now.
Okay. It's coming up now? Okay, awesome. Okay, so I'm going to talk about Azure Cosmos DB. I'm part of this small team here. We've been very blessed by our customers. We are one of the fastest growing platform on the Azure, and the idea here is that we are trying to solve issues which plague uh, developers, IT pros, and end of the day result in a business uh, saving of some kind. Okay. So what the agenda that we'll follow is a little bit of walk of the portal, of the capabilities that we have, and then focus on the issues, right? And to make sure that I did a review with one of the MVPs, uh, and then he suggested to add a few more slides. So I said, okay, let's add a few more slides. As it is morning there, they will have a little bit more time for me. So let's just do that. You might have heard there is quite an amount of buzz about the platform. If you look it up, we have been, fortunately, this is good things happening. This also means that we are moving up in a lot of people's radars in terms of what we provide and how we provide, the capabilities that we provide, and the execution in terms of our vision. So what is Cosmos DB, right? The way we think of as it is a globally distributed multi-model database service which can scale out to petabytes of data. The way to read this particular slide is to go from bottom up. The bottom is our platform. Our platform provides distribution. Our platform provides elastic throughput and storage. Our platform provides guaranteed low latency at 99th percentile. I will talk about it in a little bit more detail later. And then provides choices of the consistency levels. And to top it all these guarantees are backed up by financial SLAs. So we are the only database who provides all these things. The platform provides the core performance, core distribution capabilities. On top of it, we basically go ahead and expose the data models. So one of the first data models that we supported was document. As part of it, that journey, we exposed the document DB API, which you can think of basically querying and storing the documents using SQL. You could also write JavaScript on the server side and do manipulation of the documents. This year, we went ahead and introduced a few more data models. One of the first was the key value. The key value data model was supported by the table API. And I'll talk about it if you're interested, what it does and all that thing. But the idea here is that there are a lot of customers, table customers, who wanted a lot of premium features in terms of ability to get more throughput, ability to get its secondary indexes, and all of those things we provide out of the box. So we provide no friction, migration, and adoption of our platform through this particular API. Then we also introduced last year MongoDB API, which is a document DB, which works from document DB data model. The idea here being, again, the customers who are using MongoDB, if they need performance, if they need global distribution, if they need low latency experience, they take existing data, put inside the Cosmos DB platform, use existing code as it is, and use existing tool as it is. And that's the wire level compat that we provide. We also introduced graph model, which is today exposed by Gremlin, which is just a traversal language for querying the data which is inside in a graph model. So end of the day, what we are trying to do is provide a base platform which exposes a data model which can be extended to various APIs. And you will see a lot more additions as we go along. If there are questions, we'll take them right at the end. So let us cover a few of the use cases. So we have Skype. So just to give an example, who store a lot of data across Teams and the Skype itself in terms of both the ingestion as well as a lot of heavy query which is going on. So that is it is a globally distributed system. We basically support almost 44 terabytes of data, of the message data, about 1 terabyte of group data, and 6 terabyte of user data. These kind of workloads or these kind of sizes are very difficult to get with normal databases. And since it is also globally distributed, they get the advantage of providing low latency experience to their users. Okay. Then we have, we work with a lot of first-party automobile manufacturers to provide them IoT platform capabilities. This particular customer uses the Cosmos DB platform to store the telemetry data and analyze that data and provide recommendations in terms of what to do next. So we have about 8 terabytes of data at this point of time and growing, and they basically store telemetry from various set of cars. We are working with other set of customers in similar areas. Then we have the e-commerce application vendors. We're working with many of them. One of the example is jet.com. What they also require, one of the key case is that they want elasticity. Just like the Cyber Mondays, Black Fridays, you want an ability to cater to a lot more customers on particular set of time. And then you want to do this in an elastic way. We serve a lot of use cases, but the specific one here we are talking about where we surface the order processing for them. And this also, what they do is they increase the throughput on certain days, and then they decrease the throughput. This is something which is the part of the elasticity that we provide. And then we have the games and a whole set of things. I'll not get into all more details, but we have a lot of game developers who use us to store data. And as you know, they grow very fast, and then they require very low latency experience. So in pretty much all these cases, you can see a lot of data, low latency experience, global distribution. All of them are basically the key factors in pretty much all these use cases. So what do we do differently from everybody else, right? So what we do is first is, let me just take a break here and just make sure that before I get into that, just show you how it looks like. So let me get a viewpoint and okay. So let me, has anybody used Cosmos DB from set of attendees who are here? So Shivraj, just to answer your question, yes, Cosmos DB works with the link framework. It basically supports, we support key-based authentication. So you can develop anything else on top of it. So we don't have any restrictions on any of those pieces. So concurrency management, I may want to understand what you're trying to do, but the key part that we provide is we do provide we do make sure that you can control the concurrency using e-tags. So if there is conflict, you manage the conflict, and then we throw that error saying that, hey, you were trying to update something. This was the value earlier, but this is the value now. Now you take a decision. Okay, great. Okay, so let me make sure that I show you something before I get long. So what I'm going to do now is I'm going to walk you through how to create portal experience, and then Ravi is there, our resident CLI and PowerShell expert to whom we all look up to. So he will take whenever he has time a stab at what all we do through PowerShell, right? So whatever you can do through the portal, pretty much everything you can do through the PowerShell or the CLI. There is a small difference, and I will talk about that small difference as we go along. So what we're going to do, we're going to create an account, we're going to create a collection, and we're going to just store some data and query it. And then I'll walk you through a bunch of abilities of the Cosmos DB platform. Okay. So first thing is, when you want to create a Cosmos DB account, so you just search for Cosmos DB. And what it will ask you is two set of things. One is the name, another is the subscription set, there is resource group, and which location you want to create it. The important part here is the API. Why is this important? Because this tells us how you want to use this particular account. Today, this difference is there because we have a lot of customers who come in from who are already using one of these platforms, and they want to use these pieces. Over a period of time, you will see changes here as we go along. But the key part here is if you are a MongoDB user, you want to use MongoDB API, you use MongoDB account. If you want to use document data model and use our native document DB API, which is a SQL, you can use that. If you want to store key values, you're migrating from Redis, you're migrating from Memcache, or you're just migrating from Azure Table, you use this particular API. And for storing graphs, you just use the graph. So once you choose that, since this activity is the only one which takes a little bit of time because we go ahead and provision, I have already created a bunch of these accounts. So we'll go into one of the accounts. Okay. So let me make sure that I can get that. So let us do one simple thing. So this account has been already created. So once the account is created, normally what will happen is this collections that you see here is all empty. You will have to create a collection. This example is the native document DB API example. I will show you the MongoDB and I will show you the other pieces as we go along. So the key part here is once you come here, you will add a collection. Collection is where you store the data. So let's try to add it. Okay. So what does it ask us for? It will ask us a name, IT Pro Demo, and it will ask how much storage you need. You can start from 10 GB and we can increase the storage as we go along, or you can say, hey, I want something more because I'm going to grow, definitely going to grow more than 10 GB. There is a small difference here. When you say 10 GB, the capacity is, the throughput is an important part. Now, what is the throughput? If you want to create a database, what you think of is, okay, how do I do capacity planning around this? How much memory I need? How many cores do I need? What is the kind of disk I need? What is the kind of SAN I need? We have taken away all that worry. We just request you how many requests you're going to make and what kind of request you're going to make, and just put that number. We will provision everything behind the scenes and you don't have to ever touch and feel them. You get that particular instance which is completely isolated, and you get guarantee for this particular throughput. Okay, how do you calculate this throughput? So what you can do is this, we have a capacity planner. Here I'm just taking an example of the for the document DB. So in this case there will be a JSON document that we look into, but for pretty much it applies in similar way for pretty much all other APIs too. So let us take an example here. That would be, I think, somewhere here. So let me pick up one of these. So this is actually should be somewhere, if I remember. So this JSON looks like this. This is the kind of data that we are going to store. Okay. This data, this is the one row of data that we're going to store in, just to give an idea of, okay, there is a row or column or something. We don't have a concept of a column or something. We just store entity and then we figure out what are the columns inside. So in this case, all these would be various columns. They are not really columns for us, but practical purposes for us to understand for folks who are not very familiar with this kind of system. Just think of these are the columns which we will in for ourselves. Okay. So here, let us say we want to store 1 billion odd documents. We will do about 100 odd creations per second. We will do 1,000 reads and some updates. If you provide updates, you have to give us the document again. So just calculate the number of RUs which are required. So you would require about 2,500 RUs. So you come here and you just go ahead and say, okay, I need 2,500 RU. And what is this RU per minute? RU per minute is the elder cousin or elder brother of the RU per second, right? So this throughput that you allocate is allocated at per second level. But there are many workloads like IoT or some kind of spiky workloads. When you do ETL at irregular times, you would require more throughput than what you allocated. So in that case, you enable RUPM. And what we do is we allocate 10 times the capacity of whatever RUPS that you allocated to us, so that you can burst and take advantage of that capacity. The idea being that since we are a provision system, we basically want to ensure that you get the complete throughput that you have allocated, and you don't get throttled for any of those pieces. The other important piece here is, which is common across all the APIs, is the partition key. Why is partition key required? Because remember, we can grow up to petabyte size database only when we can scale out, right? Partition key is the one which helps us to scale out. Okay, so let's go ahead and, in case the partition key is something, I have chosen ID, but could be anything else. Something which is unique enough to distribute the data well. Okay, if you use SQL Server, if you use Oracle or something, or Cassandra or something like that, you would know that in SQL Server or Oracle, we partition the table for various reasons. One is for performance, another is for taking in and out the data whenever we need. Here we need the data to here we need the partition to distribute the data. That's the key. That's a small difference that we have. Okay. Once you do this, go ahead, provision it. So it will be provisioned. So that's pretty straightforward, right? What are the things that you can do with it, right? So I normally do is I do a few things. I use this particular, first thing is just create something, right? In this case, you can provide the ID. Let us say Ravi1, and there is a name. And so on and so forth, as many things. You would definitely not do this here, right? You would most probably do this through your SDK, through your client, and you will insert data, you will query all the data. So let's go ahead and do that. So you store the data, and then of course, right, you query this data. So let's pick up that data which was present, and there it is, right? So it is nothing dramatic, nothing big deal. You created a collection, you did something. But now let us come to some of the important pieces that you or me as an IT pro are worried about. We have created a database which has got certain amount of throughput. We want to scale it up. You can scale it up through PowerShell, CLI, or you can scale up through webhooks and matrix. I'll show you what it looks like. And then you can scale it up through the code itself. Okay. Or you can come, of course, here. Let us say this was IT Pro Demo, which was already 2,500. I need 3,000, right? And let's go ahead and save that. And it is instantaneous. There is no waiting. There is nothing. You did not have to bring in a node, set it up, and then replicate the data. Nothing. The throughput just comes in. Okay. So this is and then of course the other part is, when you don't require this throughput, you can go down, right? This, I would say, is one of the key pieces that you and me struggle with. Whenever there is capacity crunch, how do I make sure that I get the throughput that I need without worrying about all the hardware thinking that I need to do today? Okay, this is one first part. Now the other thing that you're worried about, as you rightly mentioned, is what about the indexing, right? And I will get into that part. What we do is we take away all your indexing worries. By default, across all our APIs, we auto-index all the data which comes in. Now, is that cool or what? Why is that cool? Because then the friction of starting up with the database is very, very low. You don't have to worry about creating various kind of indexings, finding out whether index is getting used or not. You just go ahead, create collection based on the throughput that you require. Make sure that you have the right partition key to distribute the data, and by Jove, you also got the index already done for you. But if you want to modify it at any point of time, you can go ahead and modify. We provide range indexes, hash indexes, and geospatial indexes. By default, we index everything. Okay. The key part is that while we index everything, we provide a low latency. While we provide indexing, we provide all the guarantee for low latency and a global distribution. So you don't have to worry about this if there is any impact on performance or so on, anything like that. Okay. But you can change it. Why would you change it? You would change if let us say there is 2 megabyte of document that you're storing or 2 megabyte of data that you're storing. Not all of that data is queried or displayed. So you can switch off that indexing by providing us the various paths that you don't want to index. Okay, so that's the second part that you worry about. What is time to live? Time to live is there's a lot of data. I collect, let us say, those IoT kind of data. Once I collect it, I calculate some aggregates and I basically throw away the older data because I don't want to really have it. So you can set it up at a container level or you can set it on an individual document level. Okay, those are the two parts. Now, what about the security, right? By default, all the data in Cosmos DB platform is encrypted at rest. Okay, so and when you connect to the Cosmos DB endpoint, it is on a TLS endpoint. So that is also, so data in motion is also encrypted. Okay. Now, the other pieces is how do you connect, right? So the way you connect, and I will show you various ways to connect it. There is a concept of a key. So we basically use the key and you can rotate these keys. That's why we provide you two keys. So you can have primary or the secondary key and then keep rotating them as and when you need them. Okay, so this is the connection string that you pick up and add to your application and start using it. Why read-only keys? Read-only keys is because sometimes you just want to provide read-only access to the data. You don't want to provide the write access at all. So that's why you get this particular key, right? We provide firewall. Why would we provide firewall? So that you want to control which particular IP can access the database account, right? So once you say that, you give us the IP. And then we will only ensure that only the IPs that you want us to connect with, only those are honored, and rest everything is rejected. Okay. Then you would be worried about how do I control from the security perspective, who can use it, who cannot use it, what did Govind versus what did Ravi do on this particular system. So we have an ability to create various users and the roles. We also log all the control plane activities that each one of us does. So this is what I was doing here on these. So whatever I have done is logged. By the way, since we are all IT pros, you will be also interested in, hey, I need an audit log of what really happened every operation. So we are working on those capabilities too. If you're interested, we have a private preview running. You can let me know. We can enable that for your account and we can work with you, where you can get where we can push the data about what is happening on account per request basis and share that data with you, right? Then the most important thing, right? There are a few important things, right? There is one thing which is the key part of the Cosmos DB platform, and that is the global distribution. This is the key part, and this only becomes much more better if I show you something which is actually distributed across the world. So first things first, right? Today you need to set up a database and it has to be available in multiple regions. What do? You have to set up either a replication with a SQL or Oracle. You have to set up always on or related kind of technologies. If you have done log shipping, you would do something similar in other databases. If it is NoSQL databases, you have to set up a cluster. You have to make sure that the clusters can talk to each other and so on and so forth. Here you don't have to do anything. We are a Ring 0 service. We are present in all Azure data centers. You just go ahead and pick and choose which data centers you want this particular database to be present at. And as soon as you pick that, we will make sure all the data is available on the other side. So it takes some time, a finite amount of time, and after that, that particular data is available for you to read. Why would you do this? For various reasons. One is, if you are developing a globally distributed application, you want low latency experience. How can you give a low latency experience to a person sitting in India? If he accesses the data in India, right? If he has to traverse all the way to US to get the data, there is latency for him. So this is how we enable this particular piece, right? Now, what are these? What has this got to do with availability? Let us say one of the region goes down, right? If one of these region goes down at any point of time, let us say where the writes are going at this point of time, that region goes down. Automatically, we'll fail over to the regions that you've given us here in the list. And here you change the priority for all of them. and unfortunately somebody is working with this, looks like, as we are speaking, so I cannot change that. But the idea here is that you can change the which region your account should fail over in case the primary region goes down. This is one thing that you can do. The second thing you can do is manual failover. This is a unique offering of the Cosmos DB platform, where if what you can do is you can literally change where the data is getting written depending on how you want it to be. So there are customers of ours. Actually, I don't think I talked about them today, but we're a large restaurant chain who is in process of basically implementing a process where what they do is they will do writes in Australia in the starting part of the day, and then they will move over to Amsterdam for the writes for the second part of the day, and then move over to US. Okay, why would they do that? Because they find that they want to ensure that the write and reads are local to each of the region, and the number of people who order all the pizzas goes down in Australia as the day progresses. Okay. But the other reason that you would use manual failover is for doing DR exercises. And this is unique. No other platform today provides this ability to failover as and when you want it. Okay. And then you can do this all through the CLI too. You don't have to depend on us. There is a related piece to it when you distribute the data. How do you provide the consistency? But let me just switch back to the presentation and address some questions. Let me see if there are some questions before I go ahead. Okay. Would you be able to demonstrate local and also say yes? Okay. Yes. So Shivraj, yes. We also have emulator, and you can run it in the Docker. There is a Docker image of that too. If you are hip and want to try out that too, yeah. Pretty much all capabilities of our platform are there, but it is an emulator end of the day, right? It cannot do the global distribution and other set of things. It is limited in terms of number of databases that it supports and so on and so on. And when you say emulator can be run offline, yes, emulator can run offline in the sense like you don't need internet connectivity for it to run. It is something which is private to you. It runs only on your machine. Yes. Okay. So let's, you guys still there with me? Okay. Let me just run through some of the things and then make sure that I address some more of your questions. As you saw, there are unique capabilities. One of the unique capability is basically turnkey global distribution. What does this mean? This simply means that we leverage the Azure platform, which is right now more than most of the rest of the two folks combined. In terms of our ability, we are a Ring 0 service, so we are available in all Azure regions, and you can distribute your data just by clicking the region that you want to be present. Okay. As a side effect, what we also do is we also provide availability as based on this particular ability, right? So what does that mean? If the region goes down, we automatically fade over to the next region that you specify. You just give us the priority. You can have multiple regions. There are customers who choose multiple regions. Why would you choose multiple regions? Because you want low latency experience for your users in those regions. And most important thing is our client SDK is multi-homing. What does that mean? If the region fails, you don't have to change connection string. You don't have to do anything. Your same application keeps on running. Nothing. The client will just do the right thing and connect to the right region. You don't have to do anything. Okay. And as we discussed, and unfortunately I could not show you, that we do have manual failover, which is a cool capability to do DR exercise or to basically do the follow the sun kind of methodology. The other part is low latency. This is a key part of our platform too. So whenever when we provide low latency experience, so we give P99 guarantees. That simply means that it is not average or median. It is P99. So 99% of queries, the latency that you will see is what we provide. And these latencies are pretty low, and we will see them. The reads for 1 kilobyte P99 is less than 10 milliseconds. Indexed writes are less than 15 milliseconds, right? At P50, we see that the indexed writes are less than 6 milliseconds and reads are less than 2 milliseconds. All this is very important for you because you as a business owner do not have to worry about hardware, do not have to worry about how to provision, how to do capacity planning. You just think about two things, throughput and the partition key, and rest all we will take care, right from availability to performance. Okay. Now, when we do this part, there is another set of things that we do. When you distribute the data, normally what happens is you get this conundrum of whether data is consistent or not. We do not force anything on you. What we do is we provide 5 different consistency levels. Very simple way to understand is the strong is similar to what SQL or Oracle normally provide, but the eventual is what a normal NoSQL provides, Cassandra or other set of folks. But then we realized that customers need a little bit more. So we added session, bounded staleness, and consistent prefix. The way to understand consistent prefix is you want an order. Let us say eventual is there is no order. It comes in, the data can come in any order. It is eventual doesn't mean there is a lot of time. Eventual simply means that it is not at instant. It is not consistent, but it is pretty fast in terms of converging on a value. Consistent prefix just provides an order. Session makes sure that whatever writes that you do, you can see them. Like just think of a Facebook or a Twitter. When you say a like, you should see that like, right? When your friend sees that like, it doesn't really matter to you, but you should be able to see, oh, I liked it. You should be able to say, oh, that like I have seen. Bounded staleness is you want to use it when you want server to manage all the consistency, saying after 5 minutes, all these regions should be consistent, and we will take care of all that guarantee to you. Okay. And most importantly, all these consistency things can be overridden on party request basis. Generally, IT foes don't get involved here, but it is a good idea to know that Cosmos DB provides a choice, does not enforce just 1 or 2 kind of consistency levels, and make sure that customers or developers can use whatever consistency level which is relevant to their particular domain. To give you any idea, most of our customers are using session, bounded staleness. There are customers who do use eventual, and then a bunch of them also use strong. A consistent prefix was just introduced, so we don't have a lot of telemetry data to say a lot of customers are using, but there are definitely 4 or 5 customers who needed it are using it. Okay. Now let us come to the throughput, right? The throughput, as we saw, can be increased, decreased whenever you want. That's a very key property of a platform. If you work with SQL, when I say SQL, a relational system, or even a NoSQL system, you have to worry about, oh, let me add capacity to it, let me replicate the data. All that stuff is gone. You just increase the throughput. We will make sure that you get all the benefit of increased throughput. And by the way, you can decrease the throughput when you're done with it. Right? We charge you whatever is the maximum in the hour, so you don't have to worry about a lot of things. Okay. As the other part is like, why would you do this, right? This is an example of that retailer who increases or decreases his throughput as his needs are. And a lot of our customers do this all the time. When they load the data, they increase the throughput. When they in the steady state, they again decrease the throughput. The other part is, as you saw, is multi-model and multi-API. What does this mean? As you saw in the beginning, when we were trying to create an account, we were asked what kind of account you want to create, right? So today, what we have taken, we are in a journey where we started with document data and exposed document DB API and a MongoDB API for the document data. And we introduced a table API for the key value data, and we introduced the graph API for the graph data. And you will see a lot more of these things happening. By the way, there is a little bit of interaction today. Over a period of time, you will see a lot more interaction as we support. Why we are doing this, right? Why we are doing this? Because we saw customers need this. We saw customers telling us that we want the global distribution, we want a low latency, and we want do not want to spend time on doing index management and all those things. But we don't want to change our code in many ways. So that's why we introduced MongoDB. And that's why we introduced the Gremlin, because then the folks who are using Gremlin as a query API, they can use us. Similarly, for the table customers who want a lot more than what Azure Table today provides, they basically start using our platform. Okay. There is a key underlying technology which makes all this happen. One of that is that we do not care about the schema, and we automatically synchronously index all the pieces of data while providing you the performance guarantees that we provide. Right? We provide various kind of index mechanisms, and we ensure that all this is never exposed to you. How today, if you're working with a normal relational or even NoSQL systems, you have to worry about how right from formatting the disks, striping the disk, the block sizes, the memory, or what kind of GCU you need to use. There is too much of tax. So we take away all that stuff from you. We say that we will auto-index the data. If you want to modify it, go ahead and modify it, but you don't have to worry about this stuff at all. Okay. And on top of it, we basically ensure that we provide you all the SLAs. So we provide a low latency, consistency, throughput, and availability SLAs of 99.49 basically at this point of time. So I'll just take a break and see if there are questions. Okay, you guys are still there? Any questions? Or I should continue. I will just go ahead and address some of the things that you guys are worried about. Yes. Ravi, today what we do is we are planning to integrate that with Key Vault, but there are customers of ours who take the key and store it inside Key Vault. But over a period of time, we will provide that particular integration, definitely. Yes. Shiraj, great question. As you can see, there is a place and in terms of when to use the Azure SQL and when to use Cosmos DB. As you saw that we can go up to petabytes of data. We provide the low latency guarantees. We provide auto indexing and all those things, right? With Azure SQL, you need to do a set of those things. And there are a set of things which Azure SQL will do well. Something like where you need let us say, transaction capabilities of across multiple tables and so on and so forth, which we will not be able to do, right? We basically provide transaction capabilities, but within a single collection, right? So definitely there are places where Azure SQL is important and plays a role, and it can go up to 4 terabytes, whereas we can go up to petabytes of data. So the choice is based on what kind of platform, what kind of application that you're developing and what you're looking for. Yeah, you tell me about that. Great. So yes, definitely there is a lot of choice, and I think end of the day, choice is here to help us. And security, as I mentioned, right? We encrypt data at rest, data in motion, and we provide key-based authentication. We provide audit logs, and we have a private preview of audit log of the DML operations. If you need to be part of that and you're using Cosmos DB, let me know, and we can work with you to enable that. We are compliant with a lot of requirements of that which our customers require. So ISO, HIPAA, PCI, and whole set of things, right? So just make your life easier by being compliant, so you don't have to worry about when you need to manage all the machines and all the infrastructure. Right? Then there is a TCO case study. You can look up this TCO, where we basically compare with hosted services as well as with the VM-based services, and our cost always come down very low. So now let's focus on things that you need to worry about, right? I talked about it. The key part here is that availability, you don't need to worry as a IT pro professional. You just ensure that there are at least 2 regions, so that if one region goes down, a region is available to provide read and writes. You can use secondary region for reads, you can use secondary region for writes and all those kind of things. But by default, at least have two regions, right? There are customers for us, generally they put two, at least 3 to 4, because they also plan, okay, what if 3 regions go down? What if 4 regions go down? So we can do all that because we distribute data without you worrying about it. Because if you have to do this by hand, it becomes very, very difficult, right? Even with other systems. And while we do this, we provide the consistency guarantees that I was talking about. So what you would do is you want an always-on infrastructure. You distribute the data in multiple regions, ensure that the client SDKs are talking to one account, and the SDK will take care of failing over whenever the region fails. You don't have to change a bit or nothing. Okay, this is the first part. The second part is, are there any questions? Shivraj, I will. There is, yes, Shivraj, there is a comparison that we have, and if you are really interested, you can contact me offline. I can share with you what we do and how we do. Ravikant, yes, there are migration paths. I will talk about them. There is a migration tool which will help you migrate from Mongo, which will help you migrate from Dynamo, and other set of things. We are working, but we make it very easy, right? If you're trying to migrate from Mongo today, use existing Mongo tool, do a dump, Mongo dump, and Mongo restore, and we just work as it is. You don't have to do anything, right? So let me know if you need help on any of those migrating cases, but it is pretty straightforward. What we are trying to do is we're trying to take the pain away of managing a large database, and while we were migrating, also make it very easy so that we meet you where you are, so you don't have to change the code and everything in case of Mongo and other case databases. Okay. What is the other thing that you need to worry about? As we saw in the beginning, right? Normally with NoSQL or relational systems, you need to worry about machines, you need to worry about their configuration. Here you need to just worry about the RUs, the request units. How do you get them? You go to that capacity planner, you put in a number that you think you require, and out comes the RUs that you require. And this is very important because anything that you do with the Cosmos DB platform, we take up the RUs, except of course the control plane operations. But when you read, we tell you how many RUs that you did. When you write, we tell you how many RUs you used. So every operation takes up the budget of that RU. Okay, so it is very easy for you to basically see whether you're going up or down. So now comes the important part, which is what do you monitor, right? Have you looked at Cassandra? Anybody managing Cassandra, Mongo, or anything? Cassandra, definitely. You would see there are about 800 or 700 odd parameters that you need to monitor. You need to monitor the OS, need to monitor the JVM, so on and so forth. In case of Mongo, also similar set of things, right? Here you don't need to monitor all those things. What you need to monitor is the throughput. What was the throughput that I allocated versus what I'm seeing at any given point of time? Let us say 24 hours or 7 days, and let it come up, refresh. Okay, like this is the one. Yeah, so you will see that there is the throughput was provisioned at 10K. It is consuming only a small amount of stuff, but we have served about 15 million say requests. So that is the kind of stuff that you can monitor. So this is, and you can create alerts on this. I'll talk about alerts in a bit, right? You'll monitor how much storage you're using. If it is a bigger collection, you will see a lot more storage that is getting used. Then you'll monitor the availability, because we will tell you what is the availability that we provide at any given point of time, and you can create alerts on these. And then you basically are looking at the consistency that we provide. One is that, hey, are we providing the session consistency that we guaranteed? Yes, we are providing that, right? So this is basically how we distribute the data, whether we are ensuring that the data is flowing around. So don't worry about this. I think it will be difficult for you to see what we are doing here, but this is what you monitor, right? And then you can create alerts on these, because this is the just like all other Azure monitor set of things. You can create alerts on these and say, Why would you do that? Because then either you can call a webhook in case you want to increase the capacity, if you are or the throughput of the collection, or you can increase, let us say, oh, there are a lot of there's a lot of requests, okay, maybe greater than 5K or 5,000 or something, then create an alert, or over a period of time, then call something, like do something about it. Maybe you are you want to increase the throughput, maybe you want to do something else, and this is very straightforward with this particular platform. Okay, so you see what we've done. We make sure that you do not have to touch the underlying system to do the throughput increase. You do not have to, or to decrease. You do not have to worry about index management. You do not have to worry about availability. But you have to just look at these tricks and ensure that you take the right action. And the only key one that you need to worry about mostly is the throughput. Rest all basically you can. We will make sure that we basically provide the guarantees for all these things, right? Throughput, there are chances that you can exceed the throughput that you've allocated, and you want to ensure that you meet that particular throughput requirement by either providing RUPM or increasing the throughput as and when you go. Okay, so hopefully we are still there. So what you would do is you would use RUPS by default. How do you get it? Use the capacity planner tool, and if you are seeing some spikes, use RUPM too. It is an additional thing. You have to pay separately for that. But when you would use, you have spiky workloads and you want to provide guaranteed throughput for them. Okay. So what happens when you consume more than what throughput that you have allocated? What we do is our SDK will go ahead and retry that operation after waiting for some time. You can override this because it will introduce latency, and you can also raise an error and make sure that you see why is it that you are doing this, because every operation that you do will tell you how many RUs you use. So you can find out if it is an expensive query, if it is an expensive operation, so that you can either allocate more throughput or make sure that you don't do that way. Okay, that's the second part. As you already saw, the performance and capacity management are very closely related. We do auto indexing. The only thing that you want to do in our index management is, let us say there are a lot of items that you don't want to ever query. You just remove, and you can tell it that as in the index pane, either through the PowerShell or through the CLI or through the portal or through the code, and we'll ensure that we don't index that piece of data. What are the gains for you? You will spend less write RUs. Okay, so that's one way to look at it. And then what you're really looking at is basically the amount of RU getting used, what is the latency that you're seeing, and then we also added something like a query stats. You will start seeing hopefully this on the portal too very soon. The idea being that you will find out which query is taking how much RU. Today you can do this, but you have to do this by looking at every query execution and find out how much basically RU that you use, right? So finally, hopefully you folks are still there. So what is in it for IT Pro, right? The IT Pro is if you have customers who are using MongoDB, who are using Cassandra, who are using Azure Table or Redis or Memcached or DynamoDB, and they require low latency, global distribution, availability, and elasticity, use Cosmos DB. And we can help you basically utilize wherever you are coming in from to do the migration, make it very easy for you to make sure that you get all the capabilities. With that, I will take a break and I'll share this deck anyway. You can go and basically pick up a lot more information about our platform after going here. Okay, there are a set of recordings. You can go and look up the channel line too. So let me see if there are questions. Awesome. Hey, thanks, Ron. Yes. So that is definitely the important thing. As what is happening is a lot of our customers, they store the data in one format and they want to query it a different way. To give you an example, you store graph and then you want to do document API on that and so on and so forth. All this will keep on improving. This experience will keep on improving as we go along. Our end goal is that that our base system is robust enough to provide these capability, and then you can keep building on top of us. So you don't have to have multiple databases to do the same thing. Hey, thank you very much, Chandrayan, for sharing these set of links. Thank you very much. Really appreciate it. Okay, so hopefully you get the key idea. We are a multi-model database. We provide low latency guarantees. We provide the distribution guarantees. The availability is just a click. You should on the region you can do through the PowerShell, and we provide the global distribution and availability. Oh yes, definitely, Deepak. I think you should contact Ravi, and then we have local folks at Bangalore and other UG locations. They can help you do the hands-on stuff too. So definitely. Sure, Ronan. Yes, you can share that answer. I think I will check it again. I think it should be possible to share the answer. Not an issue. Yes, Ravi, we are working with the Azure Stack team too. As you can imagine that we have the emulator. We have the emulator and Docker running. So you can imagine that we are working with Azure Stack folks too to make it work with Azure Stack. Definitely. Yes, yes, definitely. With all the news coming out from the Inspire for the Azure Stack, I know the DCOS, all the stuff that you are going to do. That is awesome. I'm looking forward to it. But hopefully you folks understand that our play in Cosmos DB is to make the life easier, not to worry about a lot of things, whether you're working on Azure Stack or working on the Azure platform itself. Yes, please. Oh, yes, definitely, Ronan. I will look it up and make sure that I think you should be able to post that question, answer, whatever I've shared. No, actually, so that is just a, so that is just, that is not, there is no restriction for those kind of things. You can, we have customers who do hundreds and thousands of basically requests per second to insert data. The idea of the Cosmos DB is that we are scaled out, right? As long as you can come in with multiple machines and you have cut your data so that you can partition the data so that you can push in parallelly, we don't care. You can push in as much as you want, as long as you have the throughput allocated for it, right? The only thing which will restrict you is the throughput that is allocated. And 10,000 requests per second is pretty huge throughput that you can allocate. Did I answer your question, Chandra? So think of the Cosmos DB platform, whether with respect to of any of the APIs, it's a scale out platform. So as long as you have pipes in front of that scaled out stuff, you can push as much as you want. So normally when people try to insert a lot of data, what we tell them is break up your data, have multiple machines, and then push in the data. And by the way, we are integrating with OMS, if it makes sense to you guys. We are planning to integrate with OMS. We are planning to integrate with Azure Monitor and all those set of things. So keep an eye for that too. Yes, I should have thought about that too. Yes. So if you're interested, if you try set of things, let me know we once we are ready for the private preview, I will make sure that you guys are for your account. We can enable that. Yeah.
Right, I think we're at the top of the hour. Let's not
Sure.
hold Govind for some more time because it's already late, I guess. Right. Um, Thanks
Yeah.
everyone for joining, and thanks Govind sir also. It's a
Yes.
great session and definitely learned a lot. We're definitely looking at MongoDB already, and this will really help us see how that knowledge can be translated into something that's cloud-based, offering like a Cosmos DB here. And any other questions, please feel free to forward all of them to me, or directly talk to Govind sir. So we'll definitely, make sure we get those answers, and of course invite folks again to talk about these new offerings and what some of these things really mean for IT pros, etc.
Yes, definitely. So that's my email, and what I will do is I'll share this deck later with Ravi so that he can share it with you folks. Yeah.
Absolutely. And this session is recorded. I'll post this recording by evening to our YouTube channel, and we'll open it for any people who have missed this session.
Sure. Thank you very much,
Thank you.
guys.
Thank
Have a
you.
great day.
You
Take
have a
care,
good day.
guys.
Bye bye.
Bye bye.